Okay, photoelectric effect, how we define a photoelectric effect. So when light falls on the metal surface, electron will start to move or electron will come out, and we call this as photoelectric effect. So example, a light, and this photoelectric effect can only be explained by particle nature. The wave nature cannot explain photoelectric effect. So light in the form of particles are also called photons. So light in the form of particle or a photon, when it hits the metal surface, the electron in the metal surface will come out, which we call photoelectrons. So energy of a photon is denoted by E. And how to find the energy of a photon? The formula E is equals to hf, where E is the energy, h is a Planck's constant, it's a constant value, and f is the frequency. This is a formula to calculate the energy of photon. So when photons strike, the minimum possible energy for electron to remove, that is called work function. If energy of this photon is more than, so E is the energy of a photon or photon energy, and phi is the minimum possible energy to remove electron, which is also called work function. The minimum possible energy required to remove electrons simply known as a work function. So if energy of a photon is greater than or equal to work function, yes, there will be a photoelectric effect. But if energy of a photon is less than work function, then there is no photoelectric effect, or electrons are not able to come out. So photoelectric effect, depending on the energy at which the energy of a photon, if it's more than or equal to the work function, and different metals have different work function, different energy they require to remove electron. So what happens when this energy is more than the work function? So remaining energy is used as a kinetic energy. So we can say energy of a photon will be, some of the energy is used as a work function and remaining energy is used as a kinetic energy. So we can say energy of photon is equals to work function plus kinetic energy. This is called photoelectric equation or Einstein photoelectric equation. Because it is difficult to find the kinetic energy of electron, so we can apply a voltage here, like we can connect this with a negative terminal. So this side is a negative terminal and electrons are also negative, so like charges repel each other. So what this plate will try to do, it will try to stop the electron, and minimum energy to stop electron, it should be equal to kinetic energy of the electron. Like example, if I say kinetic energy of the electron is 30 joule, so how much energy, electrical energy I have to supply so that I can stop this electron? So I should apply same 30 joules. So if we want to stop the electron, so if we want to stop this electron, then the electrical energy must be equal to kinetic energy, or kinetic energy should be equal to electrical energy. If kinetic energy is 20 joule or 30 joule, electrical energy should be 30 joule as well, so that we can stop this electron. So the kinetic energy, the electrical energy is given by voltage multiplied by charge. So we can say kinetic energy is equal to electrical energy, and electrical energy is voltage multiplied by charge. So it will be V into E, where V is the voltage and E is the charge of electron. So in place of kinetic energy, we can write voltage into charge. Why voltage into charge? It is convenient or easy to write as compared to kinetic energy. The voltage which can stop the electron from moving from one plate to another, that is called stopping voltage or stopping potential. So what happened, like we supply the photon in a photoelectric effect. A photon, energy of a photon is E. When it falls on the metal surface, the electron will come out. Electron will have kinetic energy. To stop this electron, we have to apply same amount of electrical energy. So kinetic energy must be equal to electrical energy, and kinetic energy is given by half mv square. Electrical energy is voltage into charge. So in place of kinetic energy, we can write voltage into charge, and the voltage which can stop the electron completely, we call that as a stopping voltage or stopping potential. Is it clear? So this equation is known as the Einstein photoelectric equation. Now, if we sketch a graph for kinetic energy and the frequency of the photon. So basically, you can see the formula for energy of a photon. The formula to calculate energy of photon is equals to HF. So if I increase the frequency of a photon, basically I will increase the energy of the photon. H is a constant known as a Planck's constant. So if I increase the energy of a photon, so when this photon will hit the electron, or electron absorb this photon, electron will come out. The work function, example, if I say metal is having a work function of 30 joules, so means minimum energy of this photon should be 30. But if it is more than 30, example, if it's 40, then what happen? Electron will come out, and remaining 10 joule, it will have kinetic energy. If I use a photon with high energy, example 50 joule, so 30 joule to absorb to come out, and remaining 20 joule, it will use as a kinetic energy. So as we increase the frequency of the photon, the kinetic energy of electron will also increase. But why it is not starting from origin? Why with a specific value? Because when the energy of a photon is less than the work function, so there is no photoelectric effect. So till this point, there is no photoelectric effect. It shows that the frequency and the energy is not sufficient to remove the electron. But if we increase more or higher, use a higher frequency photon, the energy of a photon increase, so the kinetic energy will also increase, and it will be a straight line. But we don't say it is directly proportional. Why? Because it's not a directly proportional relation, because its straight line is not starting from origin. So basically, increasing a frequency of a photon means increasing the energy of a photon, and as we increase the energy of a photon, the kinetic energy of electron will also increase. So what are the following 4 important features we obtain from photoelectric effect? Number 1, when light is shown on the metal, the photoelectron is immediately emitted. Means if the light having a frequency or energy more than the work function, then instantly electron will come out. They will not take too much time. If I say work function is 30 joule and energy of a photon is 20 joule, is there a photoelectric effect with this energy photon? Yes or no? Is there a photoelectric effect? Or if energy of a photon is 20 joule and the minimum energy which electron required should be 30. Is there a photoelectric effect? If energy of a photon is 20 and the minimum energy which we required is 30. There is no photoelectric effect because the energy of a photon is not sufficient. Energy of a photon is not sufficient to cause this emission. So that's why the electron will not come out. But as we increase the energy, like example, if another photon which is having energy of 40 joules, or if two photons are there, each of energy 20 joule, is there a photoelectric effect? Two photons each having energy of 20 joules. Is there a photoelectric effect in this case? In this case also there is no photoelectric effect. Why? Because one electron absorbs one photon. It cannot absorb two photons, so it cannot make up 40. It will remain 20 because each electron can only absorb one photon. So even if there is another photon with energy of 20, there will be no photoelectric effect. For photoelectric effect to occur, energy of a photon must be greater than or equal to work function. If for one photon, if it is less than work function, there is no photoelectric effect. So a photon with energy of 40 joules incident on a metal which is having a work function of say 30 joules. So what happened? This will absorb and it will come out with an energy of a 10 joule. Why? Because 30 joule is used to just come out and remaining 10 joule is used as a kinetic energy. For each metal, there exists a minimum frequency, and under this, no photoelectric effect will take place, and that is called a threshold frequency. What does it mean? I just explained the idea that energy of a photon depends on the frequency of the photon. You have the formula for energy is equals to hf. So photon, if I increase the frequency, means I will increase the energy. So there is a minimum frequency which can cause a photoelectric effect. So the minimum frequency or minimum, like example, I'm changing a frequency of a photon. I'm changing 2 hertz, using 2 hertz, then using 5 hertz, then using 10 hertz, and so on. So, and this 5 hertz and 10 hertz are causing, or 15 hertz are causing photoelectric effect. So the minimum frequency which required to remove the electron is called a threshold frequency. Minimum energy is called work function and minimum frequency is known as the threshold frequency. And the maximum kinetic energy is proportional to frequency. If you use high frequency photon, means the energy will be higher, so electron will come out much faster. And the photoelectric current increases with increasing the intensity. What does it mean? Like if I increase the intensity, means more photons are there. If you have the same metal, you have 3 photons. The work function of the metal is 30 joules. Here also you have work function 30 joules. Each photon having energy of 40. If I increase the intensity, means more photons are there. If greater the number of the photon, like if 5 photons are there, how many electrons will come out from this after absorbing? 5 electrons will 5 electrons will come out. But here 3 photons are there, so 3 electrons will come out. What will be the similarity? The similarity, the kinetic energy of each photon. The kinetic energy of each electron will be 10 joules. But the number of the electron, if we increase the intensity, there are more electrons. So number of the electrons will increase as we increase the intensity. But the energy or the kinetic energy of each electron will remain unchanged or same. Is it clear? So increasing the intensity means increasing the number of photons. Greater the number of the photons, greater the number of electrons come out from the metal surface. So this is about the photoelectric effect. Then I will discuss this at the last, why the wave theory, like why a wave cannot explain the photoelectric effect. But I will discuss at the last only, and why particle explain the photoelectric effect. Then the particle theory of a light, basically light is having a dual nature. When we say light is having a dual nature, it means light can behave like a wave, light can behave like a particle. The formula to calculate energy of a wave is equals to hf, and the formula to calculate energy of a particle is also is equals to hf. And frequency is, you have the formula c is equals to f lambda. So frequency is speed divided by lambda. C is the speed of light, which is 3 exponent 8. So I can say E is equals to hc divided by lambda. So energy of a photon is Planck's constant multiplied by speed divided by wavelength, or lambda. So basically, to resolve the paradox, it means, because some of the scientists, they believe that light is having a wave nature, and some of the scientists believe that light is having a particle nature. Why some of the scientists believe light is having a wave nature? Because interference, the property of interference can only occur in a wave, like either crest joined with crest, or trough joined with crest, or trough with trough. This can only happen if there is a wave. But this photoelectric effect cannot be explained by wave nature, it can only be explained by particle nature. So some of the scientists, they give theories about particle nature of a light, some give theory about the wave nature of a light. So the Einstein proposed a theory as stream of the particle. According to his theory, this is called a particle theory of the light. He explained it, you don't have to learn his theory. And on this theory, he explained the photoelectric effect. So according to him, the light travels from one place to another. Light consists of particles which are called photons. And energy of each photon is given by hc over lambda, and where h is a Planck's constant, which is 6.63 into 10 to the power minus 34. And f is the frequency of the light. If we want to find the brightness or intensity of the light, so intensity or the brightness of a light is how much radiations or how much energy is coming on unit area. For example, the intensity of a light, the meaning of intensity is how much energy is coming on unit area in 1 second. So if you have a specific surface, the light falls on this surface, where E is the energy which is coming on a specific area in 1 second, in specific time. We call that as intensity. So intensity is equal to energy coming on unit area in 1 second divided by time. What is energy divided by time? Energy divided by time is equals to power. So intensity is equals to power divided by area. So the unit of intensity, unit of power is watt, and unit of area is meter square. So it is watt per meter square. If you want to calculate how many photons are coming on unit area, so power divided by energy of a one photon. So the formula to calculate number of photons on unit area, it's the total power so to find the number of photon in 1 second coming on unit area, it's equal to power divided by energy of one photon. This is a formula. So if I need number of photon, that will be equal to power divided by energy of one photon. So power is equals to P, and energy of one photon is E. So P divided by E. How to find E? E is equals to HF. So power divided by HF. That will give you number of photons which will come in 1 second. How you can use this formula? Like example, calculate the energy of a photon of ultraviolet light with a frequency of 2.2 exponent 5 hertz, and calculate the energy of a gamma ray. Calculate energy of a photon of gamma rays with a wavelength of 8.4 exponent minus 3. How to calculate energy of a photon? Energy of a photon is given by HF, Planck's constant multiplied by frequency. So Planck constant is there, which is 6.63 exponent minus 34, and the frequency is 2 exponent 15. You will multiply and you will get the energy in joules. Same thing, the second question, the wavelength is given. So you can solve energy of a photon, the second question, E is equals to HF, and H is equals to, F is equals to, because you have the formula C is the speed of light, C is equals to F lambda. So F is equals to C divided by lambda. So energy is equals to Planck's constant multiplied by speed divided by wavelength. So Planck constant multiplied by speed divided by wavelength, you will get the energy. So it is easy to see a photon. You can identify that the energy of a photon is much higher. The photon of ultraviolet gamma rays is having higher energy as compared to photon of ultraviolet. Is it clear, this example? Is it clear, this example? Then we have a spectral lines or spectra. Basically, there are two types of spectra. Spectra here refers to A color or a band of color is called a spectra. So there are two types of spectra. One is called a line, or the first one is called continuous or a band spectrum. And the other one is known as discontinuous or line spectra. What is the difference between this spectra? Here refers to band of a color or color. Spectra or spectrum. What is the continuous meaning of a continuous spectrum? Continuous spectrum means, like example, if you have a tube which is filled with helium, and this tube is connected with electrode, so when you switch on the supply, these helium atoms vibrate. When these particles or atoms vibrate, some are giving 2 joules of energy, some are giving 3 joules of energy, some are giving 5 joules of energy, and some are giving, example, 8 joules of energy. So what happened? You will have a range that you obtain energy from 2 joule to 8 joule. So when you obtain different or range of energy, that type of spectrum is known as continuous spectrum. So the term continuous spectrum means that you have the range of energy. So when you observe, you will observe because different colors have different energy. So different colors have different energy, and with reference to that, when you will observe different colors are coming out, or this substance is giving different color. But what is the discontinuous spectrum? In discontinuous spectrum, it's an atomic level. Like you have atoms. These atoms contain electrons. When you supply energy, electron will jump to higher level. So when electron will absorb certain energy, and when it will return back, it will emit out that energy. But when it will emit out, it will only emit out a specific energy. It will not emit out like range of energy, because the difference between the shell is different for different elements or atoms. So like example, if you're taking hydrogen and it is giving 2 joules of energy. So all the atoms of hydrogen, so all these atoms of hydrogen, this is one, but there's another atom of hydrogen. The gap, the distance between the shell is same. So every time electron excite and return back, it will give or release the same amount of energy, and we call that as a line spectra or line spectrum. Is it clear? So the continuous spectrum means you have a range of energy, where line spectrum means you have specific amount of energy which is released. So you can see here, and how much energy is released, how you can identify. The energy which is released is equal to difference in the energy of the two shells. If this energy is E3, this energy is E2, shell 1 energy is E1. So when you take a difference in energy like E3 minus E2, you will know how much energy will be released. So for atom, even hydrogen, the first shell is occupied, but for all the atoms, there are 7 shells occupied depending on the number of electrons available. But when you check hydrogen, the central part of a hydrogen is a nucleus which contains neutron, proton. Around the nucleus, electrons are revolving in a shell. So you have all the 7 shell, 1, 2. So there are 7 shells in all the atoms, but in case of hydrogen, only occupied is 1, but all are available. K shell is there, L, M, N, O, P, and Q. If I supply energy, electron move to higher shell. When it will return back, it will give energy, but what energy it will release, that depends on difference of energy level. Like this energy is E1, E2 and E3. So it jump from E3 to E1. So energy release will be equal to E3 minus E1. And when we represent this in a figure, energy diagram, so shell 1 is having the highest energy because it's closer to nucleus. It's called a ground state. You can also say it's a ground state. So shell 1, shell 2, shell 3, 4, 5, 6, and 7. So as we go into higher shells, the distance between the shell reduces. So electron absorb energy. When the electron will come out, return back, it will release the specific amount of energy. If energy of this shell is 30 and energy of this shell is 20, so how much energy released? The difference of the two. And if this energy is given in negative, because this energy is used to bind the electron towards the nucleus, shell 1 is closer to a nucleus. So difference in energy, it will be E2 minus E1. So minus 20 minus, and energy of shell 1 is minus 30. So when you solve, it is minus 20 minus plus 30. So how much energy it is released? So when it will come out, it will release energy of a 10 joule or a photon of 10 joule. So electron absorb first 10 joule and then release 10 joule, but only specific amount of energy is released. And we call this spectrum or energy as a line spectrum. Different elements have different gaps between the shells. That's why they give the characteristic energy or characteristic color. So using a line spectrum, we can identify the type of element. This line spectrum is also known as the fingerprint of the element. Is it clear? Like this is for hydrogen, but if you take like sodium, you're taking a sodium. So in case of sodium, the shell difference will be, the difference between the shell is not same as like hydrogen. It will have different difference here. So maybe the first shell example having minus 50 and the second shell is having minus 20. So it will be minus 20 minus and minus 50. So that will be equal to 30. So when electron will return, it will release a photon of energy 30 joules. So line spectrum are also known as the fingerprint of the. So when electron is in its own energy level, we call that as a ground state. When it jump, so which one, like example, will release the highest amount of energy? Example, you have options A, B, C, and D. Which one will release the highest amount of energy? When it jumps from higher shell to lower shell, it will release energy. When it jumps from lower to higher, it will absorb energy. So which of them will release the highest amount of energy? Yeah, which of them will release the highest energy? A, B, C, or D? Release. So when it is coming down from higher to lower, it will release energy. So D will release the highest amount of energy, or high energy of photon with the highest energy. And which one absorb the highest energy? B is absorption. When it is going from lower to higher, it is absorption. Absorption line spectrum. When it is going from higher to lower, it is emission line spectrum. So when white light spectra means a family of different wavelength, and using a spectrometer. So this, when you see all the colors or combination of color, this is called a continuous line spectrum. Or this is called continuous spectrum, not line, continuous spectrum. But what is line spectrum? There's a picture I will show. Like you can see here, this is the line spectrum. And line spectrum, this is emission, and this one is absorption. So emission line spectrum, in which the atoms are giving out energy. Absorption means like we pass all the colors, we have a sample, like we have a, a sample, and we target this sample by all the colors. Like red is there, yellow is there, green is there, orange is there, blue, violet. So we target this with all the colors, but what happened, only one of them is able to pass. So if only, if one or few are absorbed, remaining will pass through. We call that as absorption line spectrum. So this is absorption line spectrum we pass. So for example, the red is able to pass. Example, the red is able to pass through this. The yellow is able to pass, but orange is absorbed. Green is able to pass. Blue is example also able to pass through. And violet and purple are absorbed. So very few of them are absorbed. So we call that as absorption line spectrum. Is it clear, the idea? Absorption, when the atoms are absorbing energy and electrons jumping from lower shell to higher shell. Emission, when electron return back to the same shell. Is it clear? The difference between emission and absorption line spectrum. So this is, so we pass the light, very few of them are absorbed, we call absorption line spectrum. When electrons return back, they give out specific, that what they absorb, they will release that back. We call that as emission line spectrum. And if all the colors we see, then we say a continuous spectrum, or range of a band of a color we see. Then a solar cell, how a solar cell work, or it use a concept of photovoltaic effect. What is photovoltaic effect? When light falls, a solar cell has a tendency to absorb the light energy So these solar cells, they consist of silicon semiconductor. So when the light falls in solar cell, what happens? Instead of electron will come out, because in metals the electrons tend to come out, but here when the electrons jump out from the atom, they start to move within the structure. So when these electrons start to move within the structure, what it produces? It produces a specific current, and this is called photovoltaic cell or photocell. This is how like a solar cell, solar watch, solar calculator works. So the difference, only difference in photoelectric effect, basically light falls and electrons start to move, come out in photoelectric effect. Whereas in photovoltaic or solar cells, when the light falls, the electrons start to move through or within the structure. So how a wave nature cannot explain photoelectric effect and the particle nature can explain photoelectric effect. So the inconsistency of experiment result with the wave theory. So according to a wave theory, wave is a continuous, an electron can continuously absorb energy and it should come out. So according to wave theory, so if we have a metal surface, and light is coming, or light falls on this metal surface in the form of wave. So when light falls and it's coming in the form of wave, they should not have any work function. So according to wave theory, wave is a continuous, so electron continuously absorb energy until they have enough energy, so they should come out. According to wave theory, this should happen. But practically, this is not happening. Practically, what happened? Only specific amount of energy is able to remove the electron. Not all the energy. Like example, if I place a lamp, I place a bulb or a lamp, and a metal is placed under this lamp. So I will not observe any photoelectric effect. Why I will not observe any photoelectric effect? Because this energy which is coming out from the lamp, it should be specific energy. All of the energy cannot remove the electron out. Means the energy of a photon should be higher than the energy required to remove electron. But according to wave theory, any energy, because wave is a continuous source of energy, so any energy should remove electron, but this does not happen actually. What happens is opposite. So this gives an idea that it is actually a particle theory can explain photoelectric effect, or light is behaving like a particle, not behaving like a wave. Is it clear?